Alright, topic 5-5, one-digit quotients. Our goal today is that we can solve problems with one-digit quotients. Now what you're going to notice is that our divisors that we're working with in tonight's work are always two-digit divisors. But because of the numbers that we are using, our quotients are only going to have one digit. So it's going to take some extra work to figure out what that one digit is in each of these problems. So let's start with this word problem. A theater sold 428 tickets for a show. A section in this theater has 64 seats. How many sections must there be to seat all the ticket holders? So what we're going to do is take all of the tickets, 428, and divide those into 64 seat sections. And that's going to tell us how many sections there needs to be in this theater in order to hold everybody. So let's set our problem up. We have 428 divided by 64. Now think about what that means. There's 64 seats in each section, and there are 428 total tickets. So we're trying to figure out how many sections are going to be in this theater. So let's look at our division problem. We always start with our divisor and we say 64 does not go into 4. So we're going to look at the 42. Does 64 go into 42? And it doesn't. So here's another one of those problems that becomes a little tough if we don't know our facts, because we have got to see how many times 64 goes into 428. And this is where estimating is going to really come in handy. The cover method I showed you, where you have to take one number on the dividend and one number on the divisor and cover them up, is a good place to start. Just know that sometimes it may take you a little higher than you should have gone. And if it does, all you do is move your digit down by one digit. So if we were saying 6 into 42, that would be 7 times, because 6 times 7 is 42. But if you notice, if we stick a 7 here, 7 times 4 is 28. 7 times 6 is 42, plus 2 is 44. 448 is larger than 428, so we know we can't do that. So now we have a good idea of what our quotient is going to be. Let's go back and start over with 428, the original tickets that we have sold, divided by, or divided into sections that have 64 seats in each section. Okay, 7 was too much, so let's go to 6. It's only logical to step down 1 when we're trying to figure out numbers as large as this. Okay, notice I put the 6 on top of the 8 because 64 does not go into 4. It does not go into 42. So we're looking into this entire number, okay? 6 times 4 is 24. Put down your 4, carry your 2. 6 times 6 is 36, plus 2 is 38. Okay? Go ahead and subtract. 8 minus 4 is 4. Can't take 8 from 2, so let's borrow one over here. That becomes a 3, which makes this now a 12. 12 minus 8 is 4. Now, here's where you stop and you look at your remainder. If your remainder is less than your divisor, then you know that you're okay. If it happens to be more than your divisor, then you've not used a large enough number up here. So we're finished with this problem. Our answer is 6, remainder 44. Okay, so you see it takes a little bit extra time when we're dividing into such a large number. Okay, so let's look here. And I've got a couple of little blue boxes here for us in case we want to try the cover method. But let's look at the problem first. This problem is 389 divided by 74. Okay, 74 does not go into 3. 74 does not go into 38. So once again, we are looking at this entire number to figure out how many times 74 goes into it. If you want to try the cover method, remember if you cover 1 in the divisor, you have to cover 1 in the dividend. Now it looks a little bit more manageable. 7 goes into 38. Well, I know 7 times 5 is 35, so that would be a good place to start. So let's start with a 5, and remember we're going over the 9 because we're looking at the entire number. 5 times 4 is 20. Put down your 0, carry your 2. 5 times 7 is 35, plus 2 is 37. Hey, this one worked. Then you subtract. 9 minus 0 is 9. 8 minus 7 is 1. I look at my divisor and I look at my remainder. My remainder is less than my divisor, so I know I'm in good shape. 5, remainder 19. Now let's look at checking this just to make sure we're right. In order to check a division problem, if you take the quotient, which is your answer, and multiply it times the divisor, and add whatever remainder you have to it, it should work out if you've done it correctly. So let's take 74 times 5. 5 times 4 is 20. 5 times 7 is 35, plus 2 is 37. Add your 19, or your remainder, to it, and you should get your dividend that you started with. 9, 8, and 3. And we did. So we know that we are in good shape. This one is correct. Okay? Let's try another one. Pause your computer at this point and work this one, and come back when you're finished, and let's see how you did. Okay, I want to show you another way. If you don't want to do the cover method, there's another way that can help you work this quickly. And basically, let's look. 28 doesn't go into 1. 28 doesn't go into 11. So we're still looking at 28 into this whole big number, 119. One thing that helps some people is to come over to the side of their paper and just multiply 28 by different single-digit numbers until you get close, but not over, the dividend. So I'll start with a 5, just because 5's in the middle and it's a good place to start. 5 times 8 is 40. 5 times 2 is 10, plus 4 is 14. So I know 5 is too much. Let's try 4. 28 times 4. 4 times 8 is 32. 4 times 2 is 8, plus 3 is 11. Look, I'm very close to 119 and I'm not over. So I know that 28 is going to go into 119 4 times. I know 4 times 28 is 112 because I just worked it out. Now if I subtract, my remainder is less than my divisor, so I know I'm in good shape, and my answer is 4, remainder 7. Let's make sure we're right, so let's multiply it out. 28 times 4. Remember, you're always multiplying your divisor by your quotient, and you should get your dividend. 8 times 4 is 32. 4 times 2 is 8, plus 3 is 11. Add my remainder to it, which is 7. And my answer is 119. Perfect. All right, let's try one more. Go ahead and pause your computer. Work this one. Come back and let's see how you did. All right, in this one, I'm going to cover, well, let's go back and look first. 36 doesn't go into 2. 36 doesn't go into 23. But 36 does go into 234. So I'm going to use cover on this just to kind of see if it'll help me. Oh, this makes it so much easier. 3 goes into 23. I know 3 times 7 is 21. So maybe I'll try 7 first. Let's see. 7, and remember I'm going over my 4 because I'm going into this whole number. 7 times 6 is 42. 7 times 3 is 21, plus 4 is 25. Whoops, we've gone too high. Okay, the logical thing to do is to move down to 6. 7 was too high, let's try 6. 6 times 6 is 36. 6 times 3 is 18, plus 3 is 21. Oh, much better. Let's go ahead and subtract. I can't do this. I can't take 6 from 4, so let's borrow from that 3 and make it a 2, which makes the 4 a 14. 14 minus 6 is 8. 2 minus 1 is 1. 18 is definitely less than 36, so my answer is 6, remainder 18. Let's make sure. Let's do 36 times 6. 6 times 6 is 36. 6 times 3 is 18, plus 3 is 21. And then let's add our remainder to it. 8 and 6 is 14. 1, 2, 3. Read over to 234. Perfect. All right, so hopefully I've shown you two different ways that you can do this, whether it be the cover-cover method or taking just your divisor and multiplying it by single-digit numbers until you get close to where you need to be. Now, on your notes page, here's what I'd like you to do first. I think you're kind of hopefully getting in the habit of doing learning goals. It's real important that we know what our goal is as we do each of these lessons. So in part 1, I want you to pause the video, tell me in your own words what our learning goal was in this lesson. Please remember, I'm going to get a little pickier as we go. I want to see a complete sentence. Talk to me like a 5th grader in a complete sentence in your own words and tell me what we were trying to accomplish tonight in this lesson. Pause the video. All right, part 2 in your video, I would simply like you to write this problem down and work it on the section that says part 2. 115 divided by 12. Pause the video. And now part 3. In part 3, I would like for you to explain to me with your words, what are you going to do if your remainder is ever larger than your divisor? What does that tell you? And what should you automatically know that you need to do if that ever happens? You can go back through the video if you need to and look. But hopefully that's something that you picked up on. It's real important and it will help you as you continue to work problems like this. If there's anything that you didn't get, feel free to flip back through the video and watch the problems being solved another time. We'll see you tomorrow in class. Great job.